Good evening, everyone. My name is Manny Young, and I would love to welcome you all to PyData Global 2021. I'm really happy to be here, and I'll be the host of this session. Today, I would like to introduce our speaker. Today with us, we have Megan Yao, and she would be actually giving a talk today on simplifying testing of Spark application. Megan is a data scientist at Spotify, and prior to her joining Spotify, she worked as a data scientist at Sobeys, one of Canada's largest grocery retailers. She's actually a contributor to, she's a contributor to Fugue, and also an app, which is an abstract layer that keeps code and computation native to Python, yet easily portable to Spark clusters. So I think I would just actually hand it over to you to do the introduction, and maybe I'll increase the fonts over here. So over to you, Megan.
Thanks, Manny. Thanks for the introduction. And today I'll be talking about simplifying testing of Spark applications. I think a lot of people in the audience kind of knows a lot about Dask and whatnot. Spark is a similar kind of distributed computing framework. It's like execution is it's a lot more different, but in the essence and user experience is kind of the same, trying to achieve the same thing. So actually in the start of my presentation, I actually wanted to go over a demo. So I'll start sharing my screen. Okay, so in my demo here, I would like to show you a common NLP data processing task on a data set that I've got from Kaggle. This data set contains a large number of Wikipedia comments that has been labeled by human readers for varying levels of toxic behavior. And the reason why, and what I wanted to demonstrate here is two kind of ways of processing it. One using the Spark map in pandas / like pandas UDF way of doing things. And the second is using Fugue. And what I wanted to demonstrate here is the different ways you can kind of get to the same kind of result, and also showcase common kind of like prototyping workflow, and which is something that I would love to dive a little bit more into and give more context in my presentation later on as to what other workflows and scenarios that you would come across when developing, prototyping these Spark applications so as to deploy them later on. So in this first method of that NLP task, I am doing the kind of general imports. I have PySpark, I have Fugue, I also have pandas and some typing data types, doing some settings. I also have to instantiate kind of a Spark session in this case, and that's because the map in pandas API / like pandas UDF requires you to, it runs using Spark, so I have to do that. And in this case, I think a lot of people kind of is familiar with this. This is the pandas read CSV. It doesn't use the Spark cluster just yet. And over here, I'm just kind of printing an example of how a record were to look like. So in this NLP task that I'll be going over, it's a tokenizing task. So what that means is that I'm breaking down these comments into its individual kind of words and tokens. So over here, just I guess highlighting what that comment would look like. And in this chunk over here, this is really the meat of the processing task. And as a data scientist or developer, maybe you wanted to add some customizability to your tokenizer. So it is very reasonable for you to write this custom function in Python using regex, by removing punctuation, by stripping white spaces, by splitting them on spaces, flattening them by removing like the new line characters, removing any non-ASCII words, and even using your own kind of stop word corpus. And in this case, I am getting the corpus from NLTK, and then removing those stop words, and then finally assigning the final list of tokens to a new column called comment tokens. And one thing to note is that this is done entirely in pandas data frame. So everything from this point is kind of running on Python. And over here, this is where kind of like the Spark, I guess, syntax or PySpark syntax were to come in. So this is where you might have to, okay, I want to use like a distributed framework because I know that eventually, even though I'm kind of prototyping my logic here in Pandas and making sure that, you know, I'm able to kind of run that same function and tokenize them in a way where it would split out those individual comments. And you can see that in here that I have successfully done it. Maybe later on, you actually are going to be processing, you know, a larger set of comments, and you want to make sure that that also runs properly. So in that kind of framework, you're actually deploying your kind of function to your Spark cluster and also making sure that it can run in a distributed fashion. So what you do here is you might convert your Pandas data frame into a Spark data frame, where you would make sure that that tokenized function that you've written, you would have to kind of wrap that into a this kind of function here, so that it can so that you can use the map in Pandas API to I guess process your Spark data frame. And Spark data frame, whenever you hear that, I would think like you know, just a way to organize your data so that when you run distributed computing, all of these different nodes are able to kind of know which kinds of partitions to process your data in. So over here, we can also see that, yes, I'm very happy because I'm able to get these tokens out very similar to how I have been prototyping it locally. So up to this point, you would realize that you would have to kind of have an understanding of how to write these kind of UDFs or map in Pandas API. You would also have to realize that it only takes in like specific data types as well. And in this case, it is an iterator, and it can only also take in kind of one parameter as well. So later on, and another thing is that you also have to, you know, read up a little bit more about the schema definition of Spark data types as well. So, you know, this is not necessarily Python native, and in terms of the developer experience, I would have to kind of know how that Spark kind of syntax kind of works in order to write this. So now I wanted to show you how this function would be written in the framework of Fugue. So in terms of schema definition, one thing you would notice is that this is now done in the comments, in a comment here. And what Fugue does, it actually parses this comment to understand what data types would be an output for. And in this case, this is this exact same function. So all I had to do is say, I'm going to be adding a new column that is now a list of string. And over here, this is also actually Python native, and it is Python native because I'm using the native execution engine, which is the Python executor, in order to run my function. So in this case of my prototyping workflow, this is very similar to me, you know, writing my custom function in Python and then testing it locally. And then when it comes to deployment, AKA, you know, running on a larger data set, I am able to kind of swap this engine parameter out to Spark execution engine. And I only had to do that when I was ready to deploy my function to a Spark cluster. And as a developer, that's really nice because I don't have to worry too much about, you know, installing a JVM on my local machine, installing Spark on my local machine. I don't even have to install PySpark actually on my machine in order for the second method. And I will go a little. I'll actually explain how PySpark works in a second in my presentation as well. So just to kind of wrap up this demo. In this result PDF, I am actually outputting a Pandas data frame in this case. And if I wanted to run on Spark execution engine, and in this case, think about me using Spark execution engine on my deployed cluster, right? And in this case, it actually outputs a Spark data frame. So what Fugue allows you to do is kind of switch in between different kind of execution engines as and when you need to. And another nice additional kind of bonus about using Fugue is that you're able to also add in additional parameters to your tokenized function. So for example, if you wanted to abstract, or if you wanted to parameterize the column that you're processing your comments in, you can do that. Whereas in this case, in the first method, you would have to change your code in a bunch of different places so as to allow your tokenized function to take in that input column parameter. You would have to change it, obviously, in tokenize. You would have to change it in the map tokenize function. You would have to kind of add it in here. And then over here, once again, that restriction of only taking in one parameter, which is the iterator pandas data frame. So what this would mean is that you would probably have to kind of hard code that in here, or some other way. So yeah, so that's kind of the demo that I wanted to demonstrate. And in my presentation, I wanted to go over what's happening under the hood, right? Like I think Spark has come definitely a very long way in terms of trying to improve the native Python execution experience and keeping your functions as Python native as possible. So I wanted to dive into that. And I also wanted to break down the different workflows in order to see, to make sure that Fugue is kind of the right fit for you when you're thinking about, developing Spark applications and also handling different kinds of tests in different scenarios. So I will be switching context now to my presentation. So as promised, I wanted to talk about how PySpark actually works. So for those of you who don't know, PySpark is actually a API, a Spark API. And what it allows you to do is write Spark applications using Python syntax or the Python API. And PySpark supports most of Spark's features, such as you can see here, SQL, data frame, streaming, MLlib, and the Spark core. But what this means, and the reason for this API is because Spark is actually written in Scala, and its source code can be compiled to Java bytecode, and it has to be ran on the Java virtual machine. So the main takeaway here is that PySpark is actually not Python native. So when you do an import of PySpark and you try to execute, PySpark APIs, you're actually relying on Python, sending instructions to be ran on the JVM. I've ran into errors if you don't install your JVM correctly and things like that. So it could be a little bit cumbersome when working with PySpark. But overall, it is a very nice way to kind of access, Spark features through Python and keep your code base very Python syntax friendly. And this might face a bit of a problem for data science applications because most of us like writing in Python, right? Most data science teams, are familiar with lots of Python libraries, and you would use like scikit-learn and whatnot, and all of that code has to be executed on, Python native engine. But then when you write in PySpark, you're actually executing on the JVM. So you actually have to balance, have to balance kind of two types of logic running in two different kinds of environments. So what that means is that you want to maintain a balance of things that you need to maintain and things that you want, that you also want. So in this case, like I said, on the right, you have your Python logic where it has to be ran on the Python interpreter. And then you also have your Spark logic, which needs to be run on the JVM. And it's good to also think about what kinds of data that you need and want to process. So on the left, you might have Pandas data frames in terms of like mock data frames where you're, running very small unit tests in terms of making sure that your Python functionality works. And then or in terms of like Spark data frames where you're running kind of like an integration test to make sure that kind of your Spark application works end to end. So that brings me to the types of tests that you want to write. So like I said, an integration test that could be very similar to kind of making sure that your overall application runs when you deploy it in a distributed fashion. So making sure that, when you ingest data from your data lake and running things in Spark, making sure that that runs through together with your Python logic and your Spark logic. And unit tests, which is, writing kind of small modular pieces of code to make sure every individual function kind of works, so as to give your future kind of data scientists and developers confidence to contribute to your code base. And then the last kind of test, which is more subtle, but very important to your developer experience, is like type checks, making sure that, you have the right kinds of data types that are the right kinds of data types that you expect, so that when you deploy your Spark applications in production, your code base is expecting the same kinds of data types that you have developed it for. Yeah, so let's break that down. So that's kind of like all of the different things that you want and you need. So let's kind of break that down into this 2x2 table, in order to kind of understand the different scenarios of how you would be processing data and how that affects your kind of execution time. So on the top left, you have like a Pandas data frame and your Python logic, and that's the easiest to test because there's no cluster spin up. And on the right-hand side, you have your Spark data frame and your Python logic. You might have to encounter a Spark, your cluster spin up, because your data frames are already partitioned in a Spark data frame format. You might have to convert your Spark data frame to Pandas, which can be very expensive depending on the size of your data. And in fact, you might run into memory issues. So what some developers have done, very similar to my demo, is either wrap your Python functionality into a Pandas UDF or use the Map in Pandas API. And that way you can successfully extend functionality of PySpark, yet be able to write Python functions and be able to use Python libraries. The only thing is that it has to be serializable. So it might be a bit cumbersome to test this type of functionality, and it also might be expensive. And I'll go into a little bit more about UDFs later on. And then on the bottom left, you have your Pandas data frame and your Spark logic. And this is the case where maybe you might not think you would run into this ever, but a small, I guess like a common, one scenario could be that you have your Pandas mock data frames and you have your kind of like Spark logic that has to be coupled with like some Python logic together with the Spark logic. And because of that, you would still have to encounter cluster spin up because Spark logic has to run on the Spark cluster. And then because of that, you also have to convert your Pandas data frame to a Spark data frame. And that might be cumbersome to test as well because of that data conversion. And then finally, you have the Spark and Spark. And in this case, you're pretty happy, but you also have to encounter a local Spark cluster spin-up. So like I said, UDFs and Pandas UDFs, they might kind of come into the rescue of saving you that data conversion, because instead of converting your Spark data frames to Pandas, what Spark actually has thought about is serializing your Python function so that it is able to run on different worker nodes, and actually has seen a lot of improvements. And I wanted to also talk a little bit about the evolution of being able to run your Python native functionality on Spark and how that has improved over time. So the first kind of improvement is that running your Python logic will now encounter less time. So prior to Spark 2.3, I know we're at Spark 3.2, so this is a little bit of a like 3 years in history. So in Spark 2.3, you have the improvement of the Pandas UDF. So what that means is that Spark used the Apache Arrow project in order to help serialize some of these functions, or I guess like reserves the right to determine how to partition your Pandas series. So what that means is that in the past, Spark doesn't know what your Python function does, right? So in order to be as conservative as possible, it actually processes your data one row at a time. So that's what you see in the blue bars here. And in Spark 2.3, they came out with the Pandas UDF that actually allows them to, instead of, I guess, processing things one row at a time, it recognizes that things can be in a series, in a columnar format, and it can kind of partition it in a way where the workers can run kind of chunks of data and not just one row at a time. So what that means in terms of performance is huge performance gains. And as you can see, the largest performance gain in this case is the CDF function, which is a cumulative distribution function that is taken from SciPy. So in SciPy, it is a Python package. So that's one of the reasons why I wanted to talk about this. It's another really nice way of extending and bringing in Python functionality into Spark. So all you can see here is that the Pandas UDF outperforms the vanilla original UDF. So second improvement they've made is that it allows for Python type hints. So why that's great for testability is that you are able to write Python native type hints, keeping your Python functions even more native as it should be. Yeah, one thing to note is that on the left here, you can see that in the past, you could write them as Pandas UDF decorators as well. And you have to also specify like a specific UDF types. And there was a lot of confusion as to which type to use, what is the concept of a group map function, and how to make sure when you're using things in the right way. So the third evolution here is it actually reduced the kind of confusion as to which kind of way to use things in by introducing the map in Pandas API. So in this case, we're using kind of like the we don't have to use like the Pandas UDF kind of decorator in this case. It keeps that function as Python friendly as possible. And like I said in the start of this presentation in the demo, when you use the Pandas UDF, in order to access the Python native function again, you need to read a bit of source code to uncover how to get to it. So this actually is really nice because my function is kind of unadulterated from all of that decorator and unadulterated for any kind of like Spark kind of syntax. So this is actually kind of cumbersome to test still. And because we're, I guess, one day away from Halloween, this might be a little bit spooky to you because you still have to, the hauntings of writing additional tests still comes into play because in this case, your first function of like, this is an example of a model that you're scoring like different kinds of like data frames on. And in this case, this first function is Python native. As you can see, there's no kind of like Spark implementation here. It has to run on a Python execution engine. And in this second part, we have to kind of declare like our schema types and use the map in Pandas API where it has to use the Spark execution engine and thereby having to write two different tests for it. So that's not great in terms of like your testing experience. And the last point I wanted to drive home is that even though you might be able to spin up, a local Spark cluster, some people might be familiar with Databricks. And if you aren't, it is actually founded by the original creators of Apache Spark, and it allows developers to kind of spin up a remote cluster at a click of a button. And they also have this client library called the databricks-connect that allows you to run your PySpark. Hi, Manny. I know I have 5 minutes left and I'm trying to speed through this. And it allows you to run your PySpark functions locally, but also send those instructions to a remote cluster. And that's sometimes really nice because you're able to prototype right on your production environment, but in a very kind of local kind of setting, like in VS Code or whatnot. The downside about databricks-connect is that the first step of installing the client library is to actually uninstall PySpark, which means that you no longer take like 1 or 2 seconds to spin up a PySpark, to spin up a local Spark cluster. You might have to wait a little bit longer because you have to wake up the remote cluster on Databricks. So I know some of you are waiting as if you're trick-or-treating and you're waiting for what the punchline is here. So I wanted to introduce Fugue, which is an abstraction framework that allows users to write code native in Python or Pandas and port it over to Spark or Dask, which are distributed computing frameworks. And it allows you to keep your Python logic as native as possible, as you have seen in the demo, and keep and also keep those functions testable. And there's no need for cluster spin up unless warranted. And some of these additional benefits of using Fugue is that we have the guarantee on consistency. We understand that when you do specific functionalities on Pandas and on Spark, you might run into different results. We make sure that we are consistent according to those frameworks. And also another benefit is that you're able to save on some development and even execution time. And what I mean is that, let's say you have functions C, D, and E that uses the same helper function B. So when you're computing C, D, and E, Fugue has a special feature called the auto persist that allows you to save on some time of computing B 3 times. And then lastly,
sorry, you just have 2 minutes left, and I think if you can also use that to answer the current questions we have as well.
Okay, yeah, sure. This is my final slide, so I'll just quickly go over through this and then go to the questions. So on the schema validation, this is also really nice because it allows you to fail fast. You don't have to kind of run into these errors when you're executing later on remotely. You're able to know that this data type is wrong, and you're able to kind of fix that while you're prototyping. You're able to contact us through, we have our links here. You can reach out to us on Slack. We have documentation, and our project is found on GitHub. Spotify and Fugue, these are kind of like my 2 separate worlds, but because I work at Spotify, if you see any kind of interesting jobs, let me know. I'm happy to answer any questions. And yeah, I will go to the Q&A now. So what is the key difference between Spark 2 and Spark 3? I guess this one, there's a lot of different differences actually. So the one that I guess like you would care the most about would be I guess how it impacts the ability for Python developers to extend Spark functionality. And I would say in Spark 2.3, that was kind of like the main difference there, where it allows you to write Python Pandas UDFs and map in Pandas APIs, and allows you for a lot faster computation time. Yeah.
Great. Thank you very much, Megan. So I think if we have any other question or anything to ask, so we can move over to the Slack channel and continue our discussions over there. Thank you once again, Megan, for the talk.